Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, February 8th. Taking a quick look at significant wave heights for the North Pacific Ocean, we see a small gale off of Central California, 24-foot seas, aimed reasonably well at the coast, setting up swell for Monday. Also, of greater interest, a broader gale with 33-foot seas northwest of Hawaii, just pushing over the dateline and working its way to the east. Larger swell is expected from this system. Also noticed small area of tropical activity in the far western Pacific. Not a whole lot expected from this, but still, it's interesting to see it this time of year. First up, we take a look at jet stream level winds. These winds, up about 30,000 feet, help support the formation of gales and storms, and then help direct their track when they do form. Currently, we have good, healthy winds pushing over the dateline, 180 knots, and then into the Gulf. A remnant trough here, that is a little dip in the jet stream, is supporting gale formation off the U.S. West Coast, but not a lot of winds directly in the core of the trough to support that formation. Still, good winds either side, get a little bit out of it, and a newly developing trough here on the dateline. Again, the 190 knot winds are driving it, and notice as this deepens, that supports a counterclockwise flow in the upper levels of the atmosphere, which is also representative of low pressure in the lower atmosphere, and that is the essence of a gale. Anyway, we also have a good flow pushing under Japan. Notice the whole jet stream is basically cohesive, a little bit of a split trying to go on here near the Kuril Islands, stealing a little bit of energy from the main flow, but not a lot, and generally a quite respectable flow. Let's put this into motion. As we roll into time, notice the trough deepens here, still about 170 knot winds supporting it on Tuesday. Good support for gale formation, but also notice here the jet splits. When it wasn't split, that's what was driving weather into California. With the newly developing split, high pressure will take over the coast here and rain will cease. But continued energy pushing off of Asia. We roll this out further. The trough continues in the Gulf into Wednesday night, into Thursday, and more energy starts streaming off of Japan towards the dateline, further supporting gale development. Notice this trough here continues to hold, and a new trough starts building right to the west of it. Will it feed in? Yes, and it sort of pushes the whole pattern a bit back off to the west, more focused on the dateline. But what this suggests is continued gale development through the week into next weekend, and we'll roll this right out to the end into 180 knots. Notice the split kind of builds here along the U.S. West Coast, sort of almost a backdoor flow suggested here coming down the coast. That would mean cooler air, but not necessarily wetter air. Let's take a look down at the surface and see what's projected. Here we go. Surface level winds, surface level pressure. Notice one gale there, two gales on the dateline, a third gale over Asia, and a tropical system, actually a typhoon. First off, this system off the U.S. West Coast. As of 18Z Sunday, that's about 10 a.m., 40 knot winds pushing into the U.S. West Coast, generating seas. We saw that on the previous chart. Swell for sure for the U.S. West Coast for Monday, but likely fairly raw and jumbled given its very close proximity to the coast. A much broader gale with 40 knot winds aimed to the east and to the southeast, targeting both Hawaii, U.S. West Coast, covering a good area. Winds not particularly strong, but still good area amount, a good surface coverage. That should generate decent seas and result in decent swell. Kind of raw for Hawaii, again, given the close proximity. Groomed more for the U.S. West Coast, but also much smaller. And then a new system trying to organize over Japan. And then this, Typhoon Higos, currently just got 65 knot winds, which puts it minimal typhoon status in February in the northern hemisphere. Very significant, likely the result of a westerly wind burst that is occurring in that area at this point in time. This is standard procedure when you get strong westerly wind bursts in the West Pacific. You can get a typhoon both north and south of the equator if it's strong enough. This westerly wind burst is moderate in strength, but we'll get into that in a little bit more. Let's put this into motion. As we roll this out, the system off the U.S. West Coast heads north, pretty much starts fading by Monday. The dateline gale moves east, weakened some, 35 knot winds, but still just covering a very large area. A lot of fetch aimed right at Hawaii, but again, so that's 300 nautical miles, 600 nautical miles. So there's Hawaii. So basically 600 nautical miles, and that's not much room for the swell to evolve at all. Relative to the U.S. West Coast, we're talking 1,800 plus nautical miles. Plenty of room for the swell to groom itself, but again, also plenty of room for it to decay, and likely setting up a bit of space between all the sets pushing that direction. And then the tropical system starts fading, and as does the system over Japan, sort of getting pushed north. There was a split in the jet we saw. That's likely the culprit in regards to the system. Anyway, roll this out. The dateline system fades out into Wednesday and Thursday, 20, 25 knot fetch. Not really impressive. But given way the jet stream is, it seems apparent that yet more activity is going to form. And sure enough, by next weekend, we're supposed to start seeing the beginnings of that. First, a broad gale in the Gulf of Alaska, and another system west of the dateline. Not particularly organized, though this is starting to look better here. 174 hours out, that is Sunday night, or basically a week from now. 45 knot winds starting to take shape, but this system over here in the West Pacific is just really having a difficult time getting itself together. What it appears like is they're going to merge into a broader, more probably a system very similar to what we're seeing on the dateline currently, but that's a long ways out and not a for sure thing. Let's go take a look at what happens down at the surface in terms of sea production. So here we go. Significant wave heights for the North Pacific Ocean. We're going back in time just a little bit. Early Saturday morning, late Friday night. First, a gale off Japan. This is the big system that's currently on the dateline. And then a series of 1-2 systems, all part of a complex upper level low that was basically filling the North Pacific Ocean, but not very well organized. Instead, we got fragments of fetch along the southern periphery of this gale. Anyway, as we put this into motion, we see this is the beginning of the current system that is off the U.S. West Coast. There we go. Working up into current. There you go, 26-foot seas off the U.S. West Coast, and expected to basically start falling apart by Monday morning and moving directly into Northern California, meaning large, raw swell for Central California. A little bit better conditions and probably better shape down in Southern California. Now also go back. Notice this system that was on the dateline, 30-foot seas, working its way to the dateline on Sunday morning, sort of reorganizing. 30-foot seas again. 32, we know it's 33-foot seas in the larger picture we saw before. That it has a little bit more detail on it. And relative to the Hawaiian Islands, that's on about the 319-degree track. Relative to the U.S. West Coast, rather westerly, 283 for Northern California, and given that, 287 into Southern California, so swell for sure, all locations along the California coast to result. Anyway, we put this into motion, we go out into about Monday. This system starts fading, but it covers a good size area, nothing huge, but in terms of its coverage, maybe we can get it right there. Go, what's that? 872 nautical miles of seas. Actually, we could do it, probably better to do it about like this. That is, there you go, 1,000 nautical miles of seas, better than 20 feet, pushing towards the U.S. West Coast. And relative to Hawaii, it's about right around there, 991 nautical miles. That's a pretty good size area of 20-foot plus seas, and all, again, aimed at our main targets. Anyway, we roll this out, continues on, and notice it doesn't completely dissipate. 20-foot seas, this is roughly 30, 35 knot winds, continue into Monday, Tuesday, and even into Wednesday. Here we go north of Hawaii. That's 24-foot seas, still in close proximity of Hawaii. So more raw, large swell. The issue for the islands is going to be wind, not favorable winds either. U.S. West Coast, high pressure is completely in control. Swell will be pushing through probably the better part of dead air towards the coast. Anyway, Then finally, this system starts winding down by Friday, and that's about the end of it. And then we start looking to the next system by the weekend. On Saturday, you can see the beginnings, at least on the ocean surface, signs of fetch starting to develop, just 18-foot seas, nothing significant, and pieces off here in the West Pacific as well. But then we get into, here we are, Sunday night. Still nothing particularly impressive, but you definitely get the sense that fetch is building and that the ocean is not going to be calm and that seas are being generated. So the hope is more swell on the way. Again, the suspicion, though, is perhaps maybe windy for Hawaii. Maybe the U.S. will be locked down by high pressure. Better hope along the coast here. Next, for fun, we're going to take a look at the real long range. This is 16 days out, jet stream level winds, spaghetti plot. So it's an ensemble, a mixture of multiple runs of the model. It's this blue line that we're interested in, this especially relative to the U.S. West Coast here. And we'll just put this into motion. When the blue line reaches south of anywhere on your point here, that's roughly, just very roughly, the precipitation line. So we'll roll this out and just watch it go. Notice high pressure along the U.S. West Coast. We continue high pressure, but then you start getting into, notice as you get further out in the model, the ambiguity and uncertainty starts working its way into different runs of the models. And things get a little bit, you're not sure exactly where the main line is, but it's right here. But there's a point to this. Notice come about the 20th of February, the line starts approaching Southern California, and once it gets there, it stays there the whole way through the run, suggesting a extended period perhaps of precipitation and water. Good thing for the reservoirs, good thing for Tahoe, maybe snow. And notice, it's a flat run right across the entire Pacific Ocean. If one is to believe this, this would suggest probably a pretty good stormy pattern long term. We'll see. Next, we start looking at the Southern Oscillation Index. Difference in pressure between Darwin, Australia, and Tahiti. Notice rising pressures in Darwin, and also weekly rising pressures over Tahiti, not unexpected, but the difference suggests a net negative, minus 3.70 daily reading. And actually, notice this, we had a good deep run of negative numbers, this supported by the active phase of the MJO. Very negative numbers, both in Darwin and Tahiti. It's sort of breaking up now, but still negative. The 30-day running average down to minus 10.04. This is good. And the 90-day average, minus 7.13, all suggestive of a long-running, persistent, active phase of the MJO, and also suggestive of perhaps some sort of weak Madoki-type El Nino going on. We have been at minus 8 since the middle of October, so we're into almost 3 months now, and it really hasn't wavered more than 1 or 2 digits either side of 8. So actually, pretty good pattern. First up, surface level wind anomalies. Difference from normal. Starting February 1st, the reds and the oranges are westerly anomalies. We're most interested, and here's Asia. Here's the U.S. West Coast, the equator running right along here. It is westerly anomalies, the reds, that we're interested in. And notice, this is right in the heart of the Kelvin wave generation area. And just day after day, you just see this persistent anomaly pattern. It's starting to break up a little bit, but still suggestive of a long-running westerly wind burst in that area. Now we move to current imagery. Still strong westerly anomalies, actually moderate. We'll put them in the moderate category. It was strong earlier. Here's our tropical system. Notice westerly wind anomalies. They just make it very easy. If you get a strong enough burst here, it's just like a bulldozer plowing across here. Either side of the equator, you get a clockwise circulation, counterclockwise either side of it. Dual typhoons, that's the best scenario. This one, we only have one typhoon, but still, a typhoon in February is significant. Anyway, westerly anomalies over the entire maritime continent. By the time we get to the date line, things sort of mellow out, and then we can proceed east, south of Hawaii, basically neutral anomalies, a little patch of westerly anomalies here near the Galapagos, but the westerly wind burst is the highlight. Going a week out, we see westerly anomalies definitely settle down in the West Pacific. Again, here's the Philippines, here's the date line. Neutral anomalies over the date line, And then as we get into the East Pacific, actually some easterly anomalies. So basically, the westerly wind burst is expected to settle down, and it's only a couple of degrees either side of the equator that we're interested in, and really, it's only from 170 west off to the west. We're looking for these westerly wind bursts to create a Kelvin wave. Kelvin waves are warm water that travel under the ocean surface on the equator, erupt off the Galapagos Islands, and then start warming the Nino 3.4 region. That is this area roughly from 120 west to 170 west. When you get warm water there, that helps feed the jet stream, that supports more storm development in the North Pacific in the winter months, and that helps fuel El Nino, or actually is the main indicator of El Nino, warm water in this area. Here's another chart. We've seen this in the past. West Pacific is here. East Pacific is here. Actually, it's the whole globe. The West Pacific is actually right here, and the East Pacific is roughly here. The oranges and reds are westerly anomalies. The blues, easterly anomalies. We're looking for westerly anomalies. Notice starting about the 15th of January, good westerly anomalies started almost in the over the dateline region, and then have continued all the month of January. Here is a major pulse in the 3rd of February, and here we are the 8th. Still good solid westerly anomalies showing up, but the forecast from here beyond suggests a weakening westerly anomaly pattern. But still, we're talking at a solid month of westerly anomalies in the heart of the Kelvin wave generation area. This for sure is pushing warm water to the east, and is exactly what we want to see. Maybe not so much for this winter now, because it takes 3 months for the Kelvin wave to make it from here to the Galapagos Islands, but maybe this will be the setup for next winter. Outgoing long wave radiation model. This the statistic model. Blues are indicative of the active phase of the MJO. Less reflection off the ocean surface due to cloud cover over this area. The reds and the oranges are the inactive phase of the MJO, more reflection and high pressure. It is this area that we're interested in. The statistic model says that the current active phase of the MJO, currently over the dateline, is to slowly fade over the next 15 days and start to dissipate. The dynamic model says much the same thing, but rather than moving east, it actually continues to retrograde and holds. So the thought is, by even into the end of February, we could still be in some flavor of the active phase of the MJO. The statistic model, notice this, it suggests the inactive phase actually moves into the West Pacific. This model, which tends to do better, it has been doing better lately, suggests the inactive phase is to dissipate in the Indian Ocean, not make it into the West Pacific. That is the better of all outcomes. Then this, the upper level model, is contradictory yet again. It suggests the oranges and yellows are areas not supportive of precipitation, and it suggests that, and is also indicative of the inactive phase of the MJO. It says it's currently over the dateline. Doesn't seem like that's really the case. Maybe there's just not a great correlation between what's going on in the upper atmosphere. This is jet stream level, 200 millibar. Anyway, it suggests that this is going to push through to the East Pacific through the end of February, and then by the time we get into the end of February, the active phase takes over and continues basically the whole month of March. Very interesting. Hard to know what's going to happen here, but what currently obviously is happening is the active phase of the MJO is in control of the West Pacific. We have westerly winds, we have typhoon development. How long that will last, we would guess probably we're going to go with the dynamic model, say at least the next 2 weeks, and maybe a little bit beyond that. After that, it's hard to say. The upper jet stream model that we saw before that went out 2 weeks or 16 days also suggests the active phase of the MJO, with the jet working its way down into central California, busting through high pressure. We'll see. Hard to know, but all this generally is favorable. Next, we look at sea surface temperature anomalies, differences from normal for this time of year given any location. And the area that we're most interested in is the equator, the Nino 3.4 region, a couple of degrees either side of the equator. Draw a box right in here. If water is warm here, that's a good sign. If water is colder than normal, that's a bad sign. The warm water feeds the jet stream right up above it, up to the north, and that helps produce storms in the Dateline region and Gulf of Alaska. Currently, we have weak warming, nothing significant, certainly not El Nino, but just this persistent 0.5 to 1 degree anomaly, positive anomalies in this area, and that is feeding the jet stream to some degree. Nothing over the top, but it is helping things indeed. Now notice there are cool waters here near the Galapagos and off of Peru, that part of the upwelling phase of the Kelvin wave cycle, and we'll get into that in a minute, but it's not unusual after a series or a big Kelvin wave hits, which exactly is what happened in December, that then you get some cooling, and then the next Kelvin wave is starting to build. We've seen that with westerly anomalies over in this region, and another Kelvin wave is in development. So we expect this to just sort of dissipate out and not have a whole lot of an impact. Of course, warmer and normal waters off the U.S. West Coast, that's been the case, but that is not necessarily feeding El Nino. It is more a symptom of a developing or some sort of a weak form of El Nino, and that's currently what's going on. Here's another view zoomed into the Nino regions. Absolute wind speeds, absolute water temperatures. The key here is, notice, trades have actually reversed in the West Pacific, 160 east, west winds, and strong in this area. This is a very good sign. It is no surprise there is a typhoon that is being generated by these not westerly anomalies, actual westerly winds, and this from buoys that are stacked all along the equator here, and we have good historical data to support the finding of west winds and westerly anomalies. Now here's the actual anomalies. Notice the anomalies much more pronounced here, covering a large area. No surprise there. Actual water temperatures, 1 degree anomalies right here as the westerly winds are blowing over it. Prime area for development of a Kelvin wave, taking this warm water, pushing it to depth, creating the Kelvin wave. Also, here's our pocket of cooler anomalies. The good news is these cool anomalies actually had been over into 130, almost 135 west, about a week or so ago. They are starting to starting to fade out. That's a good sign. Not unusual, typical, again, of the upwelling phase of the Kelvin wave cycle. Next, we go take a look at depth. So here we go, West Pacific, East Pacific, and we're looking at a cross-section. This is the equator going down 300 meters or so. Here's actual water temperatures. It's not the water temperatures that matter so much. It's the anomalies. And here we go. Here's our developing Kelvin wave. 3 degree anomalies indicated. Here's the dateline right here. So this Kelvin wave is already starting to make its way to the east. The underwater or subsurface profile of the upwelling phase of the Kelvin wave. The flow is this direction. The expectation is this warm water will continue to build as westerly winds blow on the surface. They push warm water to depth. It sort of generates stews in this area, and then it starts working its way east as a cohesive unit. And then once it hits the Galapagos, starts erupting on the surface, gets caught by the trades, and then starts advecting over into the Nino 3.4 region, and that's where it starts feeding the jet stream. So this is a good sign. Another Kelvin wave in flight. It'll take 2.5 months to make it to the Galapagos. So we're talking February, March, April, May time frame. Kelvin wave erupting in the Galapagos will do nothing for this winter's storm cycle. Whatever warm water is in place, that's what's here. But what this does suggest is that perhaps we are starting to set up for more of this Modoki El Nino sort of scenario for 2015, specifically the summer months of 2015 and hopefully going into the fall. Another view of the Kelvin wave generation area. Here we go. 1, 2, 3, 4. 1, 2, 3, 4. 3 to 4 degree anomalies suggested in this. This is a bit more hyped up than the previous model. We'll go with it, but 3 degrees seems like a better call. And here, of course, is the cooling water, the last part of the upwelling phase of the Kelvin wave cycle. And satellite data, February 2nd. Here's the dateline, here's the equator, the Nino 3.4 region here. Positive anomalies suggest warm water at depth. No surprise, we know that to be the case. 5 centimeter anomalies, focused right here in the dateline region and a bit east of there. This suggests warm water at depth, and clearly we believe that to be the case. And notice no warm water here, the upwelling phase of the Kelvin wave cycle, suggesting cooler water at depth. And yet one more view. We're sort of beating a dead horse here, but it's fun to watch the progression as it goes. Early March 2014, this is the West Pacific, East Pacific. Strong Kelvin wave, the springtime of 2014. Had everyone worried about a major El Nino developing. Here's your upwelling phase of the Kelvin wave cycle, cooler water. And then we got into August, weaker Kelvin wave, better one in October, erupted in December. And now here is the upwelling phase of these two Kelvin waves. There's your cool water. And here's the new Kelvin wave being generated on the equator right now. And the expectation is this patch will do exactly like these, working their way across. If La Nina were in control right now, trades were stronger than normal, you would see no Kelvin wave activity at all. So all this is a great sign, suggesting that the atmosphere is moving in the right direction, building momentum. We wanted to see it continue into 2015. And finally, the forecast from the CFS version 2 model for Nino 3.4 sea surface temperature anomalies long term. January, we were at 0.7 roughly, and the expectation is that we're going to continue at about 0.7 through till April, June, July, and into next fall. So basically, per this model, the plan is more of the same. Modoki El Nino, not a full-blown El Nino, which is probably a good thing. You want to build a couple of years of momentum, and that's how the Modoki El Nino really works. And Modoki El Nino is an El Nino, but not really. And it just sort of, typically they gurgle along for a couple of years. You get some spikes for a couple of years, and then things might cool off for a year, and then you get some more spikes, but nothing that really hits the threshold of El Nino. And we're not going to reach El Nino thresholds this year, or not enough that it really makes any difference. But still, we're moving in the right direction after a 4-year drought of basically of La Nina being in control. This is exactly where we want to be. We want to see a slow progression over multiple years, and that helps fuel the jet stream track, helps fuel storm development, perhaps helps build snow in the Sierra, and basically just supports more surf in general, also in the summer months too, if this thing gets enough legs under it. So for right now, things are looking positive. So to wrap it all up, system off the U.S. West Coast right now, producing swell for Monday. Relatively large, but raw, probably best for Southern California. A broader gale over the dateline currently, generating 33-foot seas, targeting Hawaii well, but probably Hawaii is a little bit too close to the core of this system. Also sending good energy towards the U.S. West Coast, but much swell decay will occur over the 2,000-plus nautical mile journey to the U.S. West Coast. Still, swell is swell. We'll take it. And the models suggest yet another broad complex gale building over the dateline into the western Gulf of Alaska a week out. More of the same is expected, and the jet stream also is to dip more to the south over the U.S. West Coast, possibly bringing more rain, probably starting 9 to 10 days out, if one is to believe the models. This is all good, and of course, we have our Modoki El Nino ongoing. The drama continues there. Slow, steady development. We're looking for a multi-year pattern. That would be great. So for now, things are looking positive. There's really no bad news to report. This is a good, positive, upbeat report. We like to deliver good news. Anyway, that's it for now. Go surfing, get some waves while you can. We'll do this again next week, same time, same channel. Thanks for watching.